Hello, and thank you for joining us today for SWAN North America Alliance webinar hosted by Frost & Sullivan. Today's event is titled Uncovering Canada's Smart Water Solutions. My name is Anna, and I oversee Frost & Sullivan's Growth, Innovation, and Leadership briefings. Before we begin, I'd like to go over a few quick notes. We will have some detailed slides on today's presentation. So there's a full screen feature available in your lower right-hand corner of the webinar player. You can safely share this briefing at any time via social media, email, or blogs. And today's discussion will also be available on demand shortly after we finished. And lastly, don't forget to submit your questions throughout the session today. With that, I would now like to hand it over to our moderator, Seth Cutler.
Great. Thank you very much, Anna. Whether you've joined a previous event or joining us for the first time, welcome to everyone who's with us today. We have a very accomplished panel of utility speakers here to deliver a session focused on Canadian activity and strategies to adopt smart, data-driven water solutions. To quickly review today's agenda, first there are a few Alliance updates that I'll share with everyone here. I'll provide a quick introduction to each of today's speakers as well. After that, we will begin the panel and hear from Darrol Weiss from the City of Calgary, which is executing on a number of initiatives stemming from their updated automation master plan and vision. After Darrol, Gary Thompson from the City of Toronto will take us through a major program, the Transmission Operations Optimizer, that is transitioning them from a manual to optimized and automated operations. And we then hear from Presta from the region of Durham, who will outline the efforts they've engaged concerning the evolution of data applications and effective utility management. When our speakers have finished, I will move into a Q&A session where the panel can answer questions from everyone in the audience. As Anna mentioned, do feel free as this presentation goes ahead to submit questions, or you can do so when we move into the Q&A itself. It's always great to take advantage of the time we've managed to get from today's panelists, so do feel encouraged to participate. With that, I want to move ahead to talk about an exciting upcoming event and introduce everyone to a change in the Alliance structure going forward. The first update here is to ensure everyone knows about our upcoming workshop on the 4th of November in Montreal. This is being held in partnership with the CWWA and their National Water and Wastewater Conference and is generously sponsored by Aramosa. It's a great half-day, 4-hour event just before the conference's evening drinks reception. We have a great afternoon planned with a keynote from Guy Arnaud, Head of Water Resource Management Solutions with the City of Montreal, and further speakers from Halifax Water, Guelph Water, Aramosa, Xtelia, XPV Water Partners, OSI Soft, and Camstrip, among others. So please do join us in person. The fee is $35, but it's waived for SWAN Alliance members. We're very excited about continuing our smart water discussion in Canada, and this will be a leading event for everyone to attend. The link on this page will direct you to learn more about the day with an agenda and a further link to register. If you do have any questions or need any assistance, do feel free to reach out to me. My email is seth.cutler@frost.com. Now, a second update we have is that from the 1st of November, the SWAN North American Alliance is moving towards a membership system where access to these webinars, leading industry smart water insights, and networking opportunities will be further centralized. A number of leading organizations and partners are already members, and we do want to grow this participation, whether you're from a university, utility, a solutions provider, or another kind of stakeholder as well. Do please feel free to learn more about joining the Alliance through the address here. Really, the great part about the Alliance is the level of participation and enthusiasm from members. And so through membership, you can access important insights and networking opportunities that can reinforce your engagement with the industry, with each other, and really learning more about advances in smart water. Now, briefly, to provide a quick introduction to today's speakers. First, to speak with us today is Darrol Weiss. Darrol is the Control Systems Leader for the City of Calgary Water Services Business Unit. He leads a team of automation staff that are responsible for process control systems such as SCADA, DCS, and data historians. These systems control Calgary's water and wastewater treatment plants, transmission, and collection systems. Next, we'll then have Gary Thompson. Gary has 28 years of municipal water industry experience with the City of Toronto in the Toronto Water Division. For the past 17 years, he has held the position of Water Supply Unit Area Supervisor, Process Operations and Maintenance. Gary has also held acting manager positions at various Toronto water treatment and supply facilities, and in 2012, Gary assumed the role of City of Toronto Transmission Operations Optimizer Project Lead, a program we'll hear more about during this webinar. And our third speaker is John Presta. John is the Director of Environmental Services for the Regional Municipality of Durham. John has been a practicing professional engineer for over 25 years in the field of municipal and water engineering. He has worked in both consulting and municipal government. John is currently responsible for water supply and sanitary sewerage services for the region of Durham, which includes 25 systems and a service population of 610,000. John is currently the Water Environment Federation delegate and past president of the Water Environment Association of Ontario Board. John is a Fellow of Engineers Canada and has served as the chair of the Professional Engineers of Ontario, Lake Ontario chapter. With that, I'm happy to hand it off to our first speaker, Darrol Weiss, who will tell us more about what he's been working on to drive forward smart solutions in Calgary.
Well, hi, and welcome to our session this afternoon. It's a pleasure to be part of this. We've been working on the aspects of smart water for quite some time. For me, it kind of started in 1984, and here we are today, still delivering on automation systems. And really, it's around, how do we make the city of Calgary even a better place from an automation perspective and smart city. So with that, I mean, we basically started off with a plan. We thought about this plan in 2010, and everybody always has a lot of ideas of what automation should be and what the vision should be, and this collectively was a way to try and get everybody on board with the plan. The plan itself is a compilation of ideas, priorities, stakeholders, and really brings together all the projects that are required to deliver a good automation plan. So in your development, what we did is you come up with evaluating all your current systems, and they could be all the technology systems, they could be all your real-time control systems, your OT systems. Now you have your IoT systems, your IT systems, and getting all those stakeholders together and finding out exactly what it is that you're trying to do, what kind of standards you're trying to create, and moving into that vision piece. So really about developing a future vision of what automation looks like for everything, and that includes smart city and smart strategy. So it's taking into account all those stakeholders. It's creating a prioritization of a list of projects, if you will, that really guide you through. And they also put some dollars to that, some budgets to that, some timelines to that, and you come up with a plan. The other thing you take into account is economics. So utilizing these plans and the money that you're going to spend to develop it, how can you bring that into the economy of where you're going to save some money doing all this work? How can you optimize on your processes? And least and not last is your implementation plan. So your schedule or your look at how you're going to implement all these projects and how you're going to do it and how you prioritize it, which one happens first, which one happens last, and then all the things that occur during the plan evolution. So we developed 52 projects. This is 10 project initiatives that came out of the 52 projects. So like every other business, you have multiple systems, so it's really getting into standardization and picking out a single DCS system, maybe a single SCADA system for your business, enhancing your communication to remote sites to ensure that you've got good, reliable data. That's building in some redundancy. Putting in fiber optics. We put in fiber between the plants, inside the plants. We're using MPLS to try and move data around between our plants at a very high rate so that people that are using the information can see it and operators that are operating can see it and operate. Developing of design standards, which is so critically important, because with all these projects that are going on, and if you're in the business of water and wastewater treatment, then you know you've always got projects going on. You've got infrastructure projects going on. How do you ensure that your automation is in the design standards? You have to create those. The levels of automation. What level of automation do you require? What does the business require? What does operations require? How do you put all this stuff together so that you've got just the right level of automation so people can automate, control, and monitor that data? Selection of a single historian. We had multiple historians. We went to one historian. We bring all the information in. It comes into one platform. It's visualized one way, and it's utilized by the city of Calgary on the water services side of the business so that they can see the information, all the engineers, all the asset management folks, operational staff, maintenance staff. Security. We used this initiative to create a control system security framework. And in that framework, we also had other projects that came out of that move us towards ensuring that we've done everything we can to mitigate any issues that we could have with cybersecurity. System governance. System governance is around meeting with folks on a monthly basis, maybe every 6 months, and it's just to ensure that what you're delivering ties in with everything else. So what's IT doing? What's OT doing? What's everybody else doing in this business? And what kind of data are they bringing? What's traffic signals doing? How do we coordinate together and bring this information together and stay on plan? Developing a strategic procurement plan. So the procurement plan is vitally important, as you all know. Securing that financial money that you're going to require to implement these projects is critical. So having your finance folks, your supply management people on board is extremely important. So buckets of money. What do you do to bring money into these projects so that it's sustainable, that you can continue to deliver all those things that you come up in your automation master plan? How do you deliver them within these projects? So what we did is we created a bucket of money specifically for automation master plan projects. As well as that, we used some of the capital funding that was available for each one of the capital projects that were being delivered or thought of in the investment program. This slide here basically shows you, and again, this is only 10 projects out of 52. This shows you how you can gather all this information about your project. So now you can categorize them. You can say, you know, there's some predecessors to getting these projects done. Here's the name of the project. Here's who's responsible for it. Here's the priority. Here's how much money I need that's going to be required for this project. When the project's going to start, when it's going to end, supply management, if there's a business case attached to it and a file number that goes with that, you've got that on file so that you can always go back to that. And then, is it a priority for that year? I took one project out of the 52, and this isn't all the information around this one project, but this is enough to show you that you really, it's the project itself, the description, the consequences of not doing the project, the reasons, the recommendations, the risks the project isn't done, resources, who's going to resource this project? Will it be done by city folks in-house? Is it going to be done by consultants and contractors? And then whereabouts in project delivery does this thing show up? So you've also got your project delivery stages that talk to when you're going to have part of this project open to folks to see so that you can implement this project. Along with that comes the cost scheduling. So you know how much money it's going to cost. And also, there's a time schedule that goes with it. I didn't show it here, but it's complete. Like, you have all the information you need. You can also use this to create your business case And you can also use it as a reference to go back. So if somebody asks you a question about why you've delivered this project or why you're delivering the project, you've got all the information there. This is a snapshot of a spreadsheet that we use as part of our investment program. So Water Services has an investment program, and in there it shows the projects that we're going to do for that year, what's being spent per quarter, the totals. What's cool about this, I don't know if you've all heard about stage gating, but you can stage gate for more money or you can relinquish money, depending on where you are in your project and what's going on. As we all know, things happen with projects in the delivery stage. This is what happened to us in 2013. I call this Change Management 101. And what this is this is Calgary Bonnybrick plant, so the major plant in Calgary. June of 2013, we lost the plant. As you can see, the river inundated the whole site. All the tunnels, all the infrastructure, all those smart sensors, everything was inundated by water. And it wasn't clean water. It was river water, so it was flood water. So now you have to go back to your plan. So this is where the plan's handy. You go back to your plan, you sit down with these folks and you reprioritize. You may only reprioritize for a couple of years, but you're going to have to rebuild this plant. As you'll see in the next slide, there's a list of projects that we came up with to try and rebuild this site. So these are the projects that are going on at the site. And what's cool about it is we're able to take advantage of this huge capital program to really ensure the levels of automation that we're putting in, all the smart busing that we're putting in, all the communication that we're putting in, how we're designing control rooms, what kind of equipment we're using, what kind of devices are we going to use to visualize this information for folks, and we're able to do it throughout the whole plant. And this is a very fast project. This is probably in total probably about 7-8 years, and the flood just pushed it forward that much faster. So what we're doing is we're taking advantage of all these projects, all the capital money, and it's actually helping us with our implementation of automation at this particular site. So here's a picture of our finished site. So in this particular picture, we've added another plant. We've upgraded all the processes. We've increased its capacity, and we've put in brand new electrical systems. We've put in brand new instrumentation systems. Of course, the DCS system is being modernized as well, and it's a thing of beauty when you're done. And it just can't happen without a good plan in place. So thank you very much for your time. And at this time, I'd like to introduce our next presenter.
Hello, Gary Thompson here, City of Toronto, Quebec. Thank you very much for giving me the opportunity to present our TO success story. In my presentation today, I want to talk a little bit about what Toronto Water is, or water supply, our unit, opportunities that exist for savings, not only in our water system, but I think in a variety of systems. I'll talk a little bit about what TOO is, the software application, some of the inputs that go into TOO to generate the savings, some outputs that you get from it, as well as some of the results so far and some conclusions. I also want to thank our project partners, City of Toronto for sure, York Region, which is just north of us, and IBI Consulting Group as well. So throughout Ontario, there are a variety of water systems, and each are unique, so we're not all set up the same way. So I want to provide you some background regarding our system, and this will help you to understand how TO works and how it works for us. So Toronto, at a glance, we provide drinking water and wastewater and stormwater services for around 3.4 million people, or businesses and residences. So we have about just over $28 billion in infrastructure, and there are 4 water treatment plants, 4 major wastewater treatment plants, as well as some minor facilities. Regarding the what we do, we're the transmission system, so we're the large trunk system. We serve the residents of Toronto and York region. They're north of us. They're our biggest customer. So what we see our role is like a middleman. So we get our water from the treatment plants. We're the trunk system. We give it to local distribution water mains, which bring it to the actual physical residences. So regarding our system, I mentioned 4 water treatment plants. I don't know if some of you are familiar with them. We have the R.L. Clark in the west. We have one on the Toronto Island. That one's rated about 410 megaliters a day. We have the R.C. Harris, which some of you may be familiar with. It's quite a nice facility. It's often visited. That's about rated for 950 million liters a day, and the Horgan, which is rated for 800. The Clark I mentioned is 615. The type of pumping stations we have, we'll have a station that can produce about 240 million liters a day, and our reservoirs, some of them are quite large. So we have one of them, for example, has a total capacity of 270 million liters. Regarding our linear infrastructure, we have about 540 kilometers of main, 18 pumping stations, 15 reservoirs and tanks, so 11 reservoirs, 4 tanks. We have 126 pumping units, and our consumption is, on average, just over 1,200 million liters a day. And we have 6 pressure zones. So, the opportunity for savings. So, in our system, prior to the TOO system, as we call it, we operated in a computer manual mode. So what that means is we had pumps, we had SOPs and strategies, and we've moved to that was manually controlled, we moved to an optimized system. So what we're able to do now is to leverage those things I talked about, such as reservoir storage, automation, energy price, hydraulic modeling, historical data, to create a daily optimized pumping station schedule, right? And in this way reduce electricity use and energy costs. So what we did, we had an operator who looked at a SCADA system. They used their knowledge, their training, their experience, along with SOPs that we gave them, along with also with some energy saving strategies. They would utilize that to figure out the best pumping strategies for the day while maintaining customer service levels. Regarding electricity use, so to understand a little bit more about how TO works, we spend about, Toronto Water spends about 40 million annually on electricity. Our unit, the water supply unit, about 21 million. And our energy bill in Ontario is quite complex. So there are various components. Sure, there's a commodity charge, demand charges. We're also on the spot market. So, it's based on supply demand. If demand is greater, we pay more, and vice versa. We also have a feature called global adjustment as well. So our application, the software application, has to take advantage of that. So how does TO work? So it's a real-time online software system that automatically determines optimal pumping control strategies. So what it will do is minimize electrical energy costs, right? And it'll take into account variations in cost, planned, unplanned plant outages, demand or your storage variations, while maintaining customer service standards. So this is a custom solution that was made by us, or for us, by our partner. So I like the graphic on the right. It's actually very good in describing generally how TO works. It's a smart real-time water control system, and it has 4 inputs. These are real-time weather data, which it gets from Environment Canada, and it contains the latest 7-day forecast details. Also, it has hydro rates, so it goes to the IESO website, which is our independent electrical system operator. It shows the energy cost predictions for the day. It takes that. It also has its own predictive algorithms inside. It's able to take in the complexities as well, such as global adjustment. Other input is SCADA data, so it will look at system pressures, flows, equipment availability, pump characteristics, capacities, pump curves, all of that. It also takes in past demand data, so demand data, consumption, historical data. So you can see on the left, the diagram shows is a pretty good representation of the sophistication of TO. So it's quite sophisticated. And it has basically 4 components to it. You can just see quickly on the left a demand model, a control strategy component, which is kind of the bottom. Just above that, it has a hydraulic quality model component and a data analysis component to the right. So all of our inputs go into the TOO, the optimizer, and the output goes to SCADA. Right? And here a live operator, reviews it, and if the schedule looks good, they approve it, and then it's transferred automatically to our SCADA. On the bottom there, you'll see what a pump schedule looks like. Basically, this is what the operators are used to seeing. It gives them almost like a sheet showing when a pump starts and stops. It just allows them to quickly review because they were used to looking at it that way. A key element to TO is that it requires an operator to review and accept the solution. Let's see about it. Some key features about it. We do 3 runs a day, at 6, at 2, and at 10. TO is referred to as a hybrid system. There are really 3 types. It appears in the Environmental Science and Engineering magazine. There's an article from October 2017 that you can look at. It's a hybrid system. It allows you to run parts of the system if need be on auto and parts on manual. So it allows you to test, allows you to deal with off-standard issues, and seems to work very well. Okay, so what are the results? So the results are seen here. It was commissioned in November 2015, and you can see from the graph that it's worked quite well. So it's hard to, maybe not too hard to see here, but right at the top is 2014. So you can see that was prior to TOO. I didn't include 2015 because it was kind of wonky because of all of the testing, and it skewed the way the graph looked. But you can see definitely after that year, because it was commissioned in November of 2015, you see basically the savings, the kilowatt hour per megaliter savings annually. Right? Those are very clear results. We also have a benefits tracking tool as well, which is able to allow us to track year-on-year savings, even if our energy rates change. So some of the benefits of it, we've saved over $1 million a year in direct kilowatt hour savings. What's that equivalent to? That's 8 million kilowatt hours per year reduction. That's equivalent to about 20 million kilometers driven by the average car, 800 homes electricity use, 13,000 barrels of oil. And some conclusions. The project cost about $4.5 million. We saved about $1 million a year. The project period took about 3 years to complete. We received a Toronto Hydro incentive of $1.6 million. All of our data that I showed in the graph is Toronto Hydro validated and third-party validated. Required operator involvement was key in getting it to work. It's opened new ways for us to transmit water. It's really changed the way that we operate as a whole. Also, it's been a cultural change for us as well. Thank you for the opportunity to present, and I pass the presentation over to our next presenter, John.
Thank you. Hello, I'm John Presta, and with the region of Durham. We're located just adjacent to the city of Toronto. We have the largest geographic service area within Greater Toronto to service our customers. We own and operate 25 water and wastewater systems to serve 8 local municipalities with an asset value of approximately $8.8 billion. As we know, sound data management is essential in operating a smart water system. Data collection, we know, has evolved over the years, and we know there continues to be areas the data is entered in manually, and we definitely are moving towards automation so our systems can communicate with each other. In order to run an effective utility management, the data must be integrated into the 4 key areas, so you can, you know where the information exists for your assets in terms of operations, finance, performance, and asset. Data collection appears to be easy, as we know, through technology, electronic and digital capabilities. Now we can collect data, store data in a better manner than we did historically. However, we do need to understand the amount and the frequency of data that's required. So with the new computing power that we have, it allows us to obtain all kinds of data from our facilities, and this can obviously generate complexities based on the site-specific location and complexity of the equipment. So we decided we had to do, with all this data, we had to get organized to work more efficiently. Our first implementation challenge is basically connecting the data silos that I'm sure most utilities have, but we had them in terms of information from your SCADA historian. We had information from our environmental lab, power monitoring equipment on equipment, data that's available on the web with respect to weather and consumption of natural gas. And then, as I mentioned, there's always processes where we have a manual data system. So we wanted to implement a proven reporting and information system, and we selected ERES. ERES stands for Eramosa Reporting and Information System. It's a web-based tool capable of connecting directly to these silos of data for easier analysis and a better understanding of your data so you can make better decisions. This also helped this strategy with trying to simplify the data silos and manage it at a central depository. We wanted to make sure that it brought the data back to the operations team so they can understand how the facility is operating and have a history of performance data for process improvement. Obviously, this is not, sounds all easy, but you know, we had 4 major challenges to overcome. First, as I mentioned, the data compilation, to try to get all those sources into one area for a centralized data repository. Data handling, with ERES, it doesn't copy the data from the silo. It simply connects directly to the data source and to issue the data handling to improve human reliability. So the handling of the data is minimized, which eliminates much of the human error that may be caused. Data quality, there's data validation tools within the ERES web software to check and move away from, check the data, and also to allow flexibility to move away from manually entered data into the spreadsheets so that we can improve that process. And the fourth one was data display. ERES can display the data in multiple formats, and this provides a big advantage to our frontline operations staff. It also takes, we usually get requests for data from consultants that we're working with or stakeholders, and in terms of trying to get the data in a quicker fashion, and if we're transferring data, we know that it's reliable. This has greatly improved the process. The reporting system provides a professional report style output with the built-in report builder tool, so that it provides an official style and also helps with compliance type reporting. And as I mentioned, it's quick access to data on the go if you have ad hoc queries, and visual dashboards are easier to develop. So the four factors for success for implementation, one of them is ownership. Historically, we had used at the plant an Oracle-based reporting tool to compile in-house data only, but the user interface was not meant for the front-level operations. So the ownership of the data was originally with the IT group, resulting in a loss of engagement from our operations staff. So we returned this back with our strategy, returned it back to the operations team to use the ERES tool, and that provided, we found responsibility and accountability for the data quality that was available. Leadership, we found that we had to dedicate, our strategy was to dedicate a staff member from the plant operations team to act as a project lead and not the consultant. The staff member was able to represent operations so they can ensure their requirements were met, and the time commitment from this resource was significant and also required full-time dedication. Change management, this was obviously, when we started to embark on this or started to talk about this, it was obviously a different way of doing business. So we used the electronic logbook within the ERES format to create electronic communications log about providing updates to the staff. When we started to embark on this, it provided a door or a way of both communicating effectively across the multiple operational shifts, because at the large plant where we implemented this, we have shifts, 24-hour shifts for liquid processing, and we also have an incineration facility which requires 24/7 operation 7 days a week. The tool obviously helped to open up messaging from across the various operational teams. Included in the change management was training. We have close to 80 staff on site, and all staff were trained on the modules related to the reporting system, And the operational project lead was the trainer and not the consultant. So there was everyone knew the person, and the project lead could understand the culture better in the operations teams. And this allows for better communication in order to implement the reporting tool. We have created on phase one a number of improvements in terms of data set connections, creation of high-level reports, and basic dashboards. But next year we'll be moving into phase two, which will include alarm and event management and advanced workflows. Integrating this into the operations was crucial, and the electronic logbook and dashboard functionality will help engage with the maintenance operators that are at the plant. There was in order to assist this project and the integration of the plant, there was a pilot period for the e-logbook was established, so that would help with the operators visiting the reporting system daily and becoming familiar with the platform. And that's about it. Thank you.
Great. Thank you, John. Nice to finish up the presentations with some success factors and trying to think ahead about different plans and different ways to implement these solutions, and even back looking at the TOO and really putting in a system that delivered a three-year payback that really helped transform the utility in the way that it operates itself, and even back towards Darrol's presentation, looking towards how you really have to have a plan if you're going to move forward with some of these large automation strategies. So there's really some good takeaways, I think, from today's webinar. And really with that, I think we can move in towards the Q&A portion of the event. If anyone has questions, do feel free to submit them now. We've got some that I'm going to start with as well. One question I think that's come in that's certainly something that's often talked about in the water industry, but is how much did regulation drive your innovation? I don't know if there's a particular person here that would like to start, but looking towards regulations impact would be the first area we can discuss.
Well, John Presta, I can start off. The implementation of handling the data in a more efficient way, definitely one of the drivers was regulatory requirements, because we're under quite scrutinized about our operations with the regulator, and if you don't have the data in order to prove how you're operating in compliance, you can run into problems, and if you're not efficient in answering the questions, it doesn't relieve a good impression with the regulator. That's it.
Perfect. Gary or Darrol, do you want to have a quick comment on regulations impact?
Well, yeah, I think the regulations, they're changing all the time. So I mean, automation and how we look at automation and the types of instrumentation probably that we use, and how we coordinate that instrumentation with some of the reporting that we do, maybe some plant alerts and stuff like that. Those are things that are probably always changing for us. Currently, we're upgrading all of our instrumentation on our effluent water, and we're working together with the University of Calgary down here at one of our plants to optimize processes so that the effluent water that's actually leaving these plants is free of pharmaceuticals. So there's, like I say, it's work always in process or always in progress. So yeah, it drives your innovation all the time. Like I say, these innovation plans and projects, these are things that you put in place based on the best information that you have, but ours has been going on for 10 years, and like you say, we had a flood, regulatory changes, the University of Calgary comes on board. You know, there's always things changing the way that you direct your automation, and you know, the City of Calgary, we work hard to ensure that we try to meet all the compliances that are in place.
I mean, thanks. For us, Gary here, for Toronto, really regulation, I guess we had to design this so that we could remain in compliance. So it wasn't so much a driver as an outcome. We had to operate our system while maintaining regulatory compliance. As John had mentioned, in Ontario, we're highly regulated, so that's a key feature for us. For example, we had to be able to maintain pressures and flows and fire storage, but also have water turnover, adequately in order to maintain chlorine residuals. So we have online analyzers, which allows us to monitor the chlorine residual in our system. So overall, TO has to be able to meet our normal operating conditions while maintaining regulatory standards, particularly regarding water quality, but I don't think it was a driver per se for doing the project, but it's something it had to be an outcome.
Great, thank you. A next question here as well is just thinking about the significant percentage of drinking water losses in distribution networks. Can anyone here comment on maybe leak detection systems or strategies for pipes buried in your respective cities and coverage areas?
For Gary here, for our system, our trunk distribution system, we meter large flow pipes in from the plant, and basically out we measure consumption. So we're as I was mentioning, we're over 1,000 to 100 million liters a day, so those are really large volumes. It's harder to detect. We're pretty good. Our numbers are pretty good. I think really for Toronto Water, where that comes more into play is at the local water level, the mains. For them to find their leaks. I mean, we have a lot of our water mains are what we call the metro main. They're concrete encased, welded steel. They don't really leak. So I don't think it's a big issue for our unit water supply.
Yeah, it's Darrol here. For the City of Calgary, we've been putting in district metering. So the cool thing about district metering is you know how much water is going into a particular area or a particular district, and it may be some of your bad actors that you've identified maybe by breaks that you've had in those different districts, and then also by zone analysis. So we have a lot of water supply zones here in Calgary. We're pushing 22 zones, so it's quite a bit different than a lot of cities where you've got maybe 1 or 2 zones or 3 zones. We have 22 zones. So. And then, of course, the DMA, which really helps with identifying those leaks.
Hello, it's John. Most historically in the past, our focus on leakage has been replacing about 25,000 plastic water services made out of polybutylene. So we put approximately about $130 million program over 10 years to ensure that we replaced all those services to cut down water leaks, because they were leaking like crazy and breaking very frequently. So we're just finishing off that program, and then we'll be concentrating. We're doing some trial and error with leak detection and working with monitoring equipment that you install in hydrants. So that's where our next focus is going to be.
Perfect. And this is a question that's posed towards Gary. Can you talk a little bit about challenges you've faced in terms of keeping the modeling upon which the TOO system is based up to date so that the results of the optimization are trusted? Does your consultant need to make changes to the system to keep it up to date, or does your staff do the updates?
Oh, that's a great question. Some of the challenges in keeping up to date, fortunately, part of our TO team, we have a senior engineer. He's quite good at it. So during implementation, we would make updates to the models sort of on the fly. If we would run into issues, it wasn't matching reality, we'd speak to him, he would make adjustments to pump curves and so on. We actually have, so we're maintaining it that way. We're doing a lot of that in-house ourselves within our unit. We do have a group that, water infrastructure management group that does look after it for the entire city. But for our TO model, it's quite good. If I say so, we've turned a planning model into an operational model. And the other part of your question, can the results be trusted? Absolutely. All of our data, like when we finished the project, we received that $1.6 million hydro incentive, Toronto Hydro incentive. It was validated by them. We gave them the data. It was a third party validated it, and we're able to show the results year after year. We've been doing it long enough now that I think that's a given. Yeah, and does your consultant need to make changes to your system? We do it usually. I mean, we work with them still. There's still some things that they do. We're transitioning over to sustainment. We're transitioning some of the things that the consultant does regarding the network and work over into our own IT department. So we're taking ownership of that as well. I hope that answers your question.
Great, thank you. The next question here, just for everyone, what are the kind of the top SMART projects you're looking to tackle next? How do you aim to prioritize and balance innovation projects? You know, certainly I think we've talked about a lot of different things that are out there. There's a lot to be tackled. How do you start to kind of have things bubble to the surface and prioritize them?
Darrol here.
Oh, go ahead.
Oh, sorry.
No,
I
go
think
ahead.
what we're looking at, basically, because we're in the implementation stages, is at the system level, we're looking at virtualization. So in the virtual environment, as far as the server's location goes, it gives us a better system for redundancy and also for reliability. It also cuts down on some security issues that you can have as far as how many operational consoles you have, how they're distributed throughout your systems, and access to things like USBs and drives and items like that. By going with a thin client or a zero client, drastically reduces that security part. Plus, it reduces the amount of equipment. That would be a SMART qualifier for us. And then how we manage all those assets as we move forward. Using the virtualized servers, you do get a little bit more life than you would out of a standard server, so it changes your investment as well.
I think it's John here with the region of Durham. We're going to be putting our next efforts into connection to our new computerized maintenance management system, which is a corporately being done not only on water and wastewater side of the business, but corporately throughout the region. So we're gonna be spending most of our time ensuring the connection works.
Yeah, for us in my unit in Toronto, at least water supply, we have a group, actually another unit in Toronto Water called Process Innovation and Energy. So they're a group of mostly engineers who basically look at different ways to optimize our processes, whether it's at the treatment level or in the pumping storage level. So they were key support for us during the TO implementation. They're always coming up with different ways. We use other, we're doing a lot of other things such as, I think John mentioned ERIS type programs we're upgrading to save our historical data to utilize that. You know, from myself being involved with the TO project per se, we're looking at ways to increase automation. So we are linked with Enwave Deep Lake Water Cooling. So they use heat exchangers to provide cooling for businesses and hospitals downtown Toronto. So we find that if we can link our systems and with their automated systems, that we're able to be more efficient, things like that. That's how we're using it from the TO end. But in Toronto Water, we have a group which specifically looks at ways to, you know, to optimize and become more efficient.
Great, thank you. Darrol, this one may be kind of posed to you. It's kind of dealing with automation, but it does sort of have broader implications, I think, as well. Are there folks out there suffering with the ability to kind of achieve financial support for automation? You know, I'm sure these projects can be pretty large. How are maybe people looking to address that financially?
Currently, I mean, there are, I'll call them party financial systems that are utilized by water services. As far as how we tie into them right now, we're not doing that in an automated fashion. Like I said in my presentation, is we basically go through a rigorous, you know, budget review, and we do that probably for each political session. So for 4 years, we'll develop a budget, and then for every year we'll articulate that. And the numbers that we use, we can bring it into the system, but we don't really have any way of utilizing that currently in the system for system cost. The only thing we can do is on the asset management system is bring information in there for doing more predictive, you know, replacement times for some of our system assets. That's what we've got right now, but as we move forward, we're just, with our PI system, just moving to PI AF. So what we're planning to do there is add additional attributes from other systems. They become available. Much of what was said earlier, they're looking at a different maintenance management tool here in the future here. So how that all looks and that, I'm not sure, but we'll have a space for it where we can bring that information into our data repository and then try and utilize it there.
Great. John or Gary, do you have any maybe advice or thoughts when it comes to financing innovation in your own organizations?
Basically, we'll go through, we have an innovation team that we try to solicit ideas for innovative processes, and as long as there's a sound business case, we don't find it challenging to find the financial support as long as it's a sound business case.
Yeah, similar for us in Toronto as well. I think if you have a good project and you can demonstrate, you know, that there's efficiencies to be gained or the benefits of it, usually you can get it. I don't think everyone can hear me, but that's generally our situation.
Great. Well, thank you very much, Gary, John, and Darrol. It's really been a pleasure having you here today, and thank you again for everyone who's logged into the session today. There are a couple more questions that weren't answered. I'll get those answers for you and email them back to you after the event. This webinar will also be archived online. Should anyone that wasn't able to make it, your kind of colleagues or peers, feel free to direct them towards this webinar. Just a quick reminder again for everyone, on the 4th of November, we're having the Smart Water Workshop at CWWA, so do feel free to follow the link and check that out. Great. So this concludes today's presentation. We hope you found today's webinars informative. If you do contact us, feel free to follow up with any other questions that you weren't able to submit today. Thank you very much. Bye-bye.